Hi, my name is Aeshanashree Naikar, anak perempuan SUGUMARAN, and my matrix number is 33DCE20F2009. Today, I will be presenting practical task 1, which is tensile test on mild steel. The objective of this practical task is to study the mechanical properties of mild steel specimen under tension load, and the apparatus used are universal testing machine, dial indicators, extensometer, scale, and vernier caliper. Step 1. We have to measure the initial diameter of the tension test sample in two perpendicular directions using vernier calipers. By doing so, you will get the measurement for the initial diameter, which is 12.55 millimeters. Step 2. We have to measure the length of the specimen between the grips using a scale, and you will get the value of the length of the specimen between the grip, that is 192 millimeters. Step 3. You have to punch a mark at a distance of 2.5 diameter. Step 4. We must insert the specimen into its position and mount extensometer on the specimen. Step 5. We should adjust the readings on the dials A and B of the extensometer to 0. The least count of extensometer is 0.01 millimeters. Step 6. At regular intervals, the load extensometer are read at regular intervals of load up to the yield point. We should measure ivory scale reading till the specimen. Step 7. Based on the tabulated reading, we have to plot a graph. Step 8. We have to plot a graph of load versus extensometer reading, and the slope obtained from the plotted graph is 2.18. Step 9. Join two pieces of test sample and measure the diameter at the neck of the specimen, and the final specimen value obtained is 7.475 millimeters. Step 10. We have to measure the final length between three punch marks, and the final length between the punch mark is 86 millimeters. Step 11. We have to tabulate the observations and calculations into a table. In order to find yield stress, we have to take the yield strength point, which is a point at which permanent deformation occurs, divided by original area. Therefore, from this graph, the yield strength point is 38 kN and the original area is 123.64 mm square. Hence, the value for yield stress is 307.34 Newton per millimeter square. Next, we have to find the value of tensile strength, and the formula is ultimate load value, which is the highest point in the graph, divided by original area. Therefore, in this graph, the ultimate load value is 57 and the original area is 123.64 mm square. Hence, the value of tensile strength will be 461.02 Newton per millimeter square. Moving on to modulus elasticity. The formula to find the modulus elasticity is 1 over least count times gauge length divided by original area times slope, where least count is 0.01 mm, gauge length is 120 mm, and the original area is 123.64 mm square. Hence, the value for modulus elasticity will be 211.46 gauge Pascal. Next, in able to find the percentage of elongation, we must use the formula final length minus initial length times by 2 over initial length times by 2 and times by 100. The value for final length is 86 mm and for the initial length is 31.15 mm. Substitute all the values into the formula and the final answer will be 38.04%. Then, in order to find the percentage reduction in area, we are required to use the formula original area minus final area divided by original area 10 times by 100. The original area is 123.64 mm square and the final area value is 43.86 mm square. Insert all the values into the formula and you'll be getting 64.53%. Lastly, we can click the check button to check our answers. That's all for now. Thank you.